Hello aspirants, morning. So today we'll handle a I would say, a very thrilling question of complex number on the argand plane, and you'll appreciate the beauty of this question. You must have come across this question many a times, and possibly you might have also seen different solutions. But let's see. The idea behind my channel is never to explore the solutions, but to explore and to investigate upon our approaches, different approaches. So that is what I'm trying to do over here, and I expect and appreciate your time and patience which you are dedicating and contributing to my channel. So the question over here is, you have been presented with three complex numbers. Okay, first one is z, I should say. Second one is iz. Okay, and the third one is z plus iz. Got it? So these are the three complex numbers. The three complex number I can simply write as z1, z2, and this one is my third complex number, which is z3. Now you have been asked to find the area of the triangle formed by these three complex numbers on the argand plane. So any 3 points, if you try to connect them, definitely you will end up having a triangle. So you need to find out the area of this triangle. So how do you proceed? There are many approaches, as I have already spoken in my previous video about complex numbers, that you got like 4 different approaches when you are trying to handle complex number. Cartesian system you can use, second is the polar form you can use, and you can use the Euler form, and finally you can use the vector form to diagnose and do your troubleshooting of the complex situation which these complex numbers present in our lives. So let's see if we have been given these 3 points on the argand plane, and when we try to join these 3 points, definitely we will be having a triangle. और triangle का area कैसे निकालेंगे? Let's see. तो क्या करना है? बहुत ही simple approach I am presenting here in front of you. So let this be my axis system. Okay, and let z1 be any point. Gotcha. So this is my z1, that is nothing but z. Now the second question is how to plot z2, which is iz. So how do we proceed? If I use the Euler form, okay, suppose I'm using the Euler's form. So if this is z, let's say r cos theta plus I sin theta. So what will be my z2? iz. So I will be having r, please come up, minus sin theta plus I cos theta. Right? Very good. So now can you do a little bit of trigonometry over here just to see if things are pretty good for you? Can I write here like this? Look closely. For minus tan theta, I'm using cos pi by 2 plus theta. Am I permitted to do so? By my trigonometry? Just tell me, can I do like this? Most of you who have done your trigonometric basics don't have any inhibition in writing z2, that is iz, in this form. And my next query is, if you are able to express z2 in this form, what does it tell you? How do you relate z1 and Z2. नाउ इट्स प्रीटी सिंपल, बस देखने से ही पता चलता है। अच्छा, Z1 जो है मेरा, अगर वेक्टर के रूप में बात करें, चाहे अंडरस्टैंडिंग अपना एक्सप्रेस करें, अगर मेरा Z1 मेरा ये है, राइट, अगर दिस इज माय Z1, तो मेरा जो Z2 का वेक्टर ओरिएंटेशन होगा, उसका प्रिंसिपल आर्गुमेंट, अब और इसका अगर प्रिंसिपल आर्गुमेंट थीटा था, तो मेरा Z2 का जो वेक्टर ओरिएंटेशन होगा, उसका प्रिंसिपल आर्गुमेंट क्या थीटा है? नहीं, उसका प्रिंसिपल आर्गुमेंट कितना से बढ़ गया है, कितना से इंक्रीमेंट हो गया है? π/2 से, करेक्ट? That means if you rotate your Z1 vector, how about the mod of Z2? It is same as mod of Z1. Both are having the same modulus, that is R. That means the length of the vector will remain the same. So all you need to do is rotate your Z1 vector by how much angle? 90 degrees. That's the trick over here. So अब Z2 को हम लोग कैसे दिखाएंगे? यहाँ पे हम लोग 90 डिग्रीज प्रिंसिपल आर्गुमेंट को अपना बढ़ा देते हैं, ओके, और यानी मॉड्यूलस ऑफ Z यानी मैग्नीट्यूड ऑफ Z1 और Z2 को सेम रखते हैं। तो देखिए तो सही है, मेरा प्रिंसिपल आर्गुमेंट को मैंने 90 से बढ़ाया, that means I have rotated by Z1 vector anti-clockwise by how much angle? 90 degrees. Okay, so I think this is the point most likely. Okay, so ये हो गया मेरा Z2 vector, करेक्ट। अब आप देखिए ये एंगल कितना है? 90 डिग्रीज है। दैट मीन्स यू हैव रोटेटेड Z1 in anti-clockwise direction by how much angle? 90 degrees. Okay, why you have done so? Because the principal argument of Z2 by this expression is clearly evident to be π/2 plus theta. So ये principal argument means positive x axis से जो एंगल बना रहा है वेक्टर, ये कितना है? π/2 plus theta. As simple as that. Now my third vector is Z3, which is nothing but the resultant of these two vectors, Z and IZ, that is Z1 and Z2. So that's pretty simple. All you need to do is you need to plot, you need to find out the resultant of these two, Z1 and Z2. For finding out the resultant, the simple thing which we do is, यहाँ से आप चुपचाप क्या कीजिए, एक पैरेलल लाइन बनाइए ऐसे, इधर भी एक पैरेलल लाइन बनाइए ऐसे, और आपका ये आ गया Z3 वेक्टर, करेक्ट, क्योंकि Z3 वेक्टर अब आपका ये हो गया। और अब देखिए Z3 वेक्टर कितना हो गया आपका? रिजल्टेंट ऑफ Z1 एंड Z2, दैट इज नथिंग बट Z1 वेक्टर प्लस Z2 वेक्टर, विच विल बी नथिंग बट योर Z plus IZ. So अब आपको इसको देखने से कैसा लग रहा है? What kind of geometrical figure it is expressing? It is showing over here. Modulus same है. Mod of Z1 is same as mod of Z2, which over here we have assumed to be R. So ये साइड का लेंथ भी R है, ये साइड का लेंथ भी R है, और आपने एक पैरेललोग्राम बनाने की कोशिश की by for utilizing the law of parallelogram for addition of vectors. So since the two sides are almost equal, almost नहीं, पूरा का पूरा equal है, and at 90 degrees, so definitely you will end up forming a square, right? अब आपको क्वेश्चन था क्या? Z1, Z2, Z3 को मिलाने से जो ट्रायंगल का निर्माण हो रहा है, उस ट्रायंगल का एरिया आपको पूछा गया था, राइट? क्वेश्चन आपसे पूछ रहा था एरिया निकालिए किसका? Z1, Z2, Z3 को मिलाने से जो ट्रायंगल बनता है। तो चलिए मिलाते हैं हम लोग Z1, Z2, Z3 को और देखते हैं क्या बन रहा है। Z1, Z2 और Z3 को मिलाने से जो ट्रायंगल फॉर्म हो रहा है वो है हमारा ये, राइट, राइट, राइट। सो और इसको अगर थोड़ा सा कलरिंग कर दें तो दिस is what the question is asking you to find out the area of this triangle. Okay, so आप तो सिंपली कह सकते हैं एरिया ऑफ स्क्वायर कितना होगा? एरिया ऑफ स्क्वायर कितना होगा, जल्दी से बताइए। एरिया ऑफ स्क्वायर मॉड जेड का स्क्वायर हो जाएगा, साइड इंटू साइड। और एरिया ऑफ ट्राइंगल, एरिया ऑफ स्क्वायर है ये, एरिया ऑफ ट्राइंगल क्या होगा, जो कि ग्रीन कलर से यहाँ दिखा हुआ है, नथिंग बट हाफ द एरिया ऑफ स्क्वायर। एम आई करेक्ट? So this is how you crack this kind of question on the argand diagram using different form of vectors. You can take an approach using the Cartesian system also, but definitely it will be quite taxing on your time. See, my friends, since you're aiming for JEE, you should understand the fact that JEE is gonna test you how good an engineer you're gonna be, right? So becoming an engineer is an art, okay? Becoming a scientist is also an art, but then as a scientist, you have plenty of time to dig deep into the matter. But as an engineer, you need to be, fast, super fast troubleshooter. सो टाइम कंस्ट्रेंट को आप नलीफाई नहीं कर सकते हैं, यू नीड टू ब्रिंग द टाइम कंस्ट्रेंट इनटू पिक्चर. सो जितना ही मोस्ट ऑफ द जेई क्वेश्चंस व्हिच यू विल फाइंड, the idea behind them is to test your out of the box thinking under time constraint. तो इस तरह क्वेश्चन जब भी रहेगा, I would suggest and insist that you take this kind of approach, जिससे कि आपका टाइम भी बचे और अप्रोच भी pretty efficient रहे. Hope you like this approach. Thanks for your time and your dedication and commitment towards my channel, little channel. So thank you for being part of the show. Please press the like and subscribe button and also press the bell icon. See you next time. Thank you.